Welcome back. Let's look at the following example. Let's say we have a bug and it is moving on the circle of radius 2 centered at the origin with constant angular speed omega. So what's omega? Well, you see what theta is. Theta is the angle between the positive x-axis and the position vector of the bug. So let's say the tip here is the position of the bug at time t, and it's theta. So the angle theta is the angle between the position vector of the bug and the positive x-axis. So then theta is basically the omega is the rate of change of theta with respect to time, which is the derivative of theta with respect to time. What do we have to do? We have to find the position vector out of t for this bug. Well, how do we do that? Well, first of all, since we know that omega is a constant angular speed and omega is the derivative of theta with respect to time, we can come up with a formula for theta in terms of omega then. So what is omega? Omega is this derivative. So if we integrate both sides here, we get that the integral of omega is omega. Remember, omega is a constant speed, so it's fixed. So the integral here would be omega t plus a constancy, and the integral of derivative of theta with respect to time would be just theta. So then we see that theta is equal to omega t plus c, and for simplicity I'm going to set c to 0, so we get that omega is we get that theta is just omega times t. Okay, so at the so let's say again at time t, let's say this is the position of the bug, and then theta is the angle between its position vector and the x-axis. So at this angle, what is the position vector then? Well, that is, I want to know the x and y coordinates of this point. Well, clearly in this right triangle, remember the hypotenuse here would be 2 because the radius of the circle is 2. So x divided by the hypotenuse 2 here would be cosine of theta. So then x would be 2 times cosine theta. But theta, remember, we computed to be omega t. And similarly, y divided by the hypotenuse 2 here would be sine theta. So y would be 2 sine theta, and theta is again omega t. So then we see that the position of the bug at time t is given by the vector out of t, which is 2 cosine omega t comma 2 sine omega t. So we have found the position vector of the bug.